quality video generation with AI on local rigs with as low as 6 gigabytes of VRAM. Today we're checking this out, and this is going to be the DeepBeepMeep test of the Wan 2.1, and the quality is good. Today we're going to test out the 1.3 and the 14B. We're also going to test out a variety of cards. We're going to be checking out a 4090. We're going to see what kind of times we can get on generation, and we're also going to be testing out the highest qualities that we'll be able to generate. One 4090, not 8 4090s, one 4090. And we're going to be also checking out a 3090. As well, we're going to be checking out a 12 gigabyte 3060. Now this one I expect to be kind of slow. And we're also going to be checking out a 3070, and of note, 3070s, 8 gigabytes. More powerful processor, but definitely 8 gigabytes. So we're going to test the limits. Can it go down that low? And what is the quality like? I hope you're excited. Let's get started. So I need to do some dusting at any rate. So I'm going to take out the GPUs, and this way we can test one GPU at a time. Now, the 4090, if you've seen some of the videos in our history, definitely take a chance to go back and check them if you haven't, does not fit in here because it is such a long card. So actually this one, I kind of just set it out here. Definitely do not do this for any sort of a long-term deployment. They need to be firmly secure wherever they're at. And let's give this a check out. We're going to go ahead and run the Python Gradio server.py and set that server name to 0.0.0.0 so that we can access it on an external interface. And I'm going to zoom this in so we can check out some of this in more detail as soon as we get this running. So there are advanced options here that you can select from. We've got the 14B text to video quant at 8 bits, which is the recommendation, and that definitely should save you some VRAM. We look at the text encoder, we've got the 16-bit because we have tons of system RAM. Sage, we've got 30%, that's the Sage 1 and not the Sage 2 extension. And I just could not get the Sage 2 extension working. Compile transformers, we have that turned on. VAE optimizations. Now, it's my understanding that if you were interested in running the lowest VRAM, so when we get to the 3070, we probably have to test this, that you'd want to enable this. It does make things twice as slow, but it is a 50% VRAM reduction. So that's a pretty sizable reduction. Does it impact quality? Couldn't tell you. Profile. There are 5 profiles, and we're going to go with the recommendation, which is the second one. This requires you to have 48 gigabytes of system RAM and 12 gigabytes of VRAM. And we're going to select the 1280 by 720. We're going to leave it at 81 frames and 30 inference steps. If you click on advanced, you can see some things you might want to go ahead and enable. So T-cache in particular is something that if you have extra VRAM, you probably definitely want to enable that. 3x speed up is one thing that, you know, that's huge here if you can get a 3x speed up. Applied, let's click generate. And we'll keep an eye on the VRAM demand here also at the same time. So we're at 9 gigabytes right now. It looks really bad up front also if you start like as soon as you hit 60 seconds and you're not even one step in. It's very, oh no, what's going on here? It's going to speed up as you get a little bit further into the process. I'm not exactly sure at what point it kicks in and starts going faster, but there is a point where it will start going quite a bit faster. And you'll see the GPU spike up to like 100% utilization at that point also. Yeah, and you can see the CPU over here. It's got a single thread somewhere that must be pegged at 100%. And it looks like it's using about 31-ish gigabytes of system RAM right now also. About 330 seconds, 335 seconds, it looks like it actually kicked in. And now we're seeing 100% GPU utilization. You can see that power spiking up there, hitting 500 watts, fan at 100%, really churning. Love to see it. But the RAM demand has stayed pretty low. So we're still 9.39. So I can see an 11 gigabyte GPU being able to probably run this, which that's really impressive if you'd be able to do that. That's a very, very large model if you're thinking about like the actual demands for the original Wan 2.1. And I've got to say, it probably would be wise to have the faster CPU. If you haven't taken a chance, when we put together this system recently, it's been featured also in the video that I did on DeepSeek, where we basically did some inference on CPU. Having the 7C13 versus the 7702, probably a much better idea. Let's take a look at some of the options that you have here. So let's zoom in a little bit more so you can see better. So this is the first release of the Wan 2.1 GP by DeepBeepMeep, and excellent engineering getting this to work, and excellent name selection also. The VRAM requirements have been divided by more than 2 with no quality loss, so that's actually pretty huge. And that's why we're able to run this on just kind of normie stuff and not have to have 48 gigabyte. So the VRAM requirements will depend greatly on the resolution and the duration of the video. For instance, 24 gigabytes of VRAM, 3090, 4090, the limits are as follows. If we're looking at 1280 by 720 with a 14B model, 80 frames is 11 gigabytes of RAM. And you can see that we're kind of creeping up a little bit. It looks like possibly on the VRAM usage by the time we're at the end of the generation, and we're about 30% through there. And it looks like it's going to be about a 30-minute generation for this 5-second clip. Okay, so that took a little bit of time, 2004 seconds for that to generate. But let's check out the quality really quick here. So I'll full screen it, and I can already say it looks pretty decent. I mean, it does look like a crab. The crab looks a little bit sus on what it's doing. I'm not sure what it's doing. The octopus looks really good. The background looks, I think, very decent. Let's move on with a much smaller size. So we're going to go with the 1.3B and the 480 resolutions. And we're going to just come down here, keep all the rest of this the same. Click apply the changes. Let's click generate and see how fast this can go. Okay, we got that done in actually really good time there. So 317.8 seconds. And let's check out the quality here. It looks like it's definitely morphed into... I'm not sure, that doesn't look like an octopus to me. Let's take a look and see what it ends up shaping out like. Well, this one definitely looks quite a bit more fake. The movement of the crab, definitely not ideal. And whatever this is, that is a scary sea creature. If I saw that scuba diving, I would I'd pee myself. All right, so let's move on now that we've got the difference in times, and that is a huge difference in times. Let's move on with the 3090s. Next up, we're testing the 3090. And this one goes on the rack much easier. All right, and it's fired up. Next, let's go ahead and make sure that we've got the 14B selected now, and we're going to test the 3090 to see what kind of speed we can get on a 5-second profile number 2 rendering. And I'll change the display resolution to 1280 by 720. We're going to leave it at 81 frames for 5 seconds, and inference steps, leaving that set to 30. And we should be able to kick this off now. Latest clip in here looks like 3,850 seconds. Whew. Pretty long for the generation of that, but the quality does look really solid. Probably the best that I've seen so far, actually. The crab hanging out, unfortunately very close to an octopus. Octopus is definitely going to turn that crab into a food source. And man, just the background looks absolutely dynamite. So it is a really realistic looking scene to me, and the crab itself looks pretty good in its motion. The octopus doesn't seem to be doing much, and there is a little bit of weirdness possibly, I guess, on the suckers around this back tentacle, but the overall, it looks very realistic. All right, so we've got the same settings basically that we had for the 4090. We're using for the second test the 1.3B, same unquant text encoder, Sage 30%, and of course VAE tiling is a new option that's present. Since I've got enough VRAM here, having that disabled seems like what you would do with this GPU, so that's what I'm testing. We've got Profile 2 selected in the T2V. I have a very simple prompt that we tossed in here, and our resolution is 480p. Number of frames should be 5 seconds worth, and it is already a little bit underway here. Have yet to see it kick up over here. All right, and that was able to generate this. I would call that a fair attempt. I'm not sure you would use that, all of it, but definitely it did a pretty decent attempt of, I guess that's a police helicopter, zooming through a city. I think that is not fantastic, but I've seen worse. I will say that. And it did that in 422 seconds with the 3090. All right, now I'm going to go ahead and hook up the 3060 12 gigabyte, 3060 12 gigabyte going in. All right, we now have our 12 gigabyte 3060, a really small card here in the system. Of course, you can check out the 3060 in the all-in-one. I think it's a pretty decent all-in-one $350 build video that I did. You can click right here over there. Yeah, you can click right over there to check that link out and watch that video if you haven't seen it yet. But overall, one of the still highest gigabytes of VRAM available on a recent-ish modern platform. The 4060s right now, prices have gone quite high on the 16 gigabyters for those. And this time we're going to do a different prompt. This prompt is going to be hopefully a little bit better. We're going to start off with the small 1.3B version, which much smaller, should be much faster. Encoder, we're going to go with the 16-bit. We're going to go with Sage for 30% faster, which I'm pretty sure both of the prior we're using also. We'll leave this on. For the optimizations, we'll leave that to auto. I hope this completes. That's one of the biggest things that I'm actually checking here is, will this complete? A little bit more of a sci-fi prompt here. The camera perspective is behind and offset from a mainly gray spaceship in orbit around a foreign planet. The large circular spaceship has huge circular bands as part of a magnetic launch system that are visibly causing space distortions as it builds up a huge plasma charge in the weapon. It is a magnetic plasma cannon. The orbital platform fires directly into the atmosphere and down onto the landmass, which can be seen to visibly have futuristic and amazing levels of technology visible from space. A second later, the planet's surface has an amazing explosion as the plasma shot ripples and blows up in a major mushroom cloud. Epic resolution and photorealistic. We're going to try this first on the lower resolution 480p and just see how long this takes. I'm going to imagine it takes quite some time. All right, and here we go. It managed to kick off and not run out of RAM. So I think we're going to be looking good until the end here. All right, and RAM usage there is at 6.3 gigabytes. Ooh, I hope this is good. Let's check it out. That was pretty bad. That was horrible. I don't know what to say. That was not what you would hope for in science fiction. If I saw this kind of slop in sci-fi, I'm for sure not watching it. Maybe it was the distortion and the magnetic rings that it didn't quite understand. Maybe I should have tried an orbital projectile. I'll try an orbital projectile instead of a magnetic thing for a plasma charge on this next attempt. I changed it here to VAE optimizations and I enabled that. That is going to be 2 times slower and up to 50% VRAM reduction. Hopefully it'll allow it to run though, because we are using the larger model here, the 14B. So we're going to find out whether or not that's going to be something that can work on this size of a GPU. Oh no! It looked like it was going to do it, but boy, that's not totally unexpected. So that did crash out. Looks like it just ran out right at the end there. I guess you could try Profile 5, which is certainly an option to do, but I think what I'm going to do instead is give it another run. So number of frames here, I'm going to reduce this by, well, we were at 81. Let's see if we can get this to run for 65 frames is 1 plus 64. 64 divided by 16 is 4 seconds. So that should be 4 seconds of video there. We'll see if we can get 4 seconds eked out of it. I feel like we came really close there. So let's see. We've got that. We've got that. T-cache is disabled. And yeah, we should be okay here. So let's give it a simple prompt. Our scene is a military helicopter navigating a downtown area that has been rampaged by a monster. The helicopter chase camera is dynamic, vibrant lighting, clean metallic textures for buildings and helicopters. The helicopter approaches the monster and shoots a missile at it. Looks like we're at about 7.49 gigabytes right now, 7.7 gigabytes or so. All right, let's see what we came up with in this 4-second clip. So that's actually really good on the buildings and the helicopter. The fire itself is, I guess that's like a flamethrower, and the position of a monster that also has a helicopter head is bizarre, but the helicopter itself here is actually pretty cool. It's got dual rotors. Very interesting. But the city is also, I think, I mean, the reflectivity on the glass, I feel like I hit upon something with that portion of it. Definitely the monster is just too nondescript possibly. But this one I'm going to keep and I'm going to mess around with in some further testing. So let's get on with that further testing now. The 3070, of course, loaded in over here. We're going to be running the 14B on an 8GB card with the full 16B quant. Like I said, lots of RAM with Sage. And we're going to be using 256 by 256 VAE tiling. That says it should be good for at least 8GB of RAM, so I hope it is. And we're just going to stick with Profile 2. I don't know if that's going to work or not, but we're going to give it a shot here. And we're going to do text to video. We have a scene that is a camera in a fixed position in space and a great view of Earth. An asteroid is on a collision course with Earth and it passes into the lower view of the frame. The asteroid has a visually impressive tail of ejected gases and small rocks. The asteroid is rotating slowly as it heads towards the Earth. The scene is captured from a wide angle, showing the vastness of space and right depth of the Earth and an ocean. The water is clear and blue, with rays of sunlight filtering through. The shot is sharp and crisp, with a high dynamic range. The asteroid zooms towards Earth. It is moving fast as it plummets into the atmosphere. And we're going to do this at the full 1280 by 720. Now, I don't think we can get 4 seconds. I think 3 seconds would be probably... That 3 seconds would be amazing if we can actually get 3 seconds. So I'm going to step this down to 49, I think it is. Let's see. Yeah, 49. And that should be 3 seconds. We'll see if that can complete and how long it takes. Of course, 8GB, not a lot to work with. Like I said, definitely optimize for having VRAM. Reasons like this are exactly why. And let's go ahead and generate it. So far, it hasn't crashed, so that's a good sign. Yeah, I think this is going to work out. So we were able to finish generating 3 seconds, and from the looks of it, I think we might have been able to cram in an extra second possibly there. Let's look at the quality. That was 3,314 seconds, and we will have some analysis at the end of this, of course, and there's some pretty interesting things that I'm going to point out that maybe people aren't thinking about quite yet. So yeah, I got that downloaded. Let's take a look here at this video. You know, the transition is weird. So this actually looks good. The first part of it, I don't know what to say. It doesn't make sense from the logistical layout of it and where things are. The continent details look fairly decent. The water details look pretty good. The clouds look pretty good. So overall, I think part of this is pretty good, but mainly we're here just testing out what is possible. And we got some more answers exactly around that. Now let's check out the 480 and see how fast we can generate at that. So we'll leave everything else the same and we will change this resolution to the 480p and our primary resolution up here. We're going to change this to the 1.3B model. I might change the prompt if I was interested in that, but I think for now we'll just leave it and say good enough. Probably pretty important if you're interested in getting higher performance. Notification, not enough SMs. So that is a there's a fixed amount of these for these streaming multiprocessors on a CUDA card, and you can look that up on Tech Power Up's website. From what I was able to see, it looks like 3090s have definitely enough, 80 of them. It looks like some cards like the 3060 and the 3070 do not have enough of them. All right, I forgot to change that from 3 seconds back to 5 seconds, but At least I caught it in the calculations, so it'll all work out here in the end. So let's see here. This is actually not that bad. Now I kind of wish I would have let this go for another 2 seconds. Could have been interesting what we might have caught. That actually is a little bit more what I was hoping for, and kind of a pivot, and then, you know, it going in. So that actually is, while it's a lower quality, definitely you can see it as a lower quality overall. It is actually much closer adherence to what I was asking for. Let's take a look at some of these numbers that I think are actually pretty interesting. And I mean, I don't know why my brain thinks this way, but such as it is, I figured I would actually do a comparison between the cost of operation per generated second and compare that to, in this instance, I'm using the 50 cents per rendered second cost of Google Veo 2. There's a lot of other platforms out there. Let me also say, this is not to say that there's not really good reasons to use one of those other platforms. Things like quality, using your own equipment, but also if they provide better quality, that probably is one of the biggest things that you would want to look at. So I have this filtered right now on the cost per second, and I'll just run you through kind of this little sheet really quick. Now, everything's calculated in US dollars, and I'm using my base kilowatt electric rate, which is 10 cents per kilowatt hour. And I'm using Google Veo 2 as the benchmark of a state-of-the-art video generating platform out there, and it is 50 cents per delivered second. So that is an expensive mistake to make if you generate a lot of seconds and it's not looking good. But boy, you might save a ton of time. Sorted this by the efficiency, and it's surprising. As far as the cost per second, there are some things that are not surprising. So we did the test at the bottom end. That was the 832 by 480 pixel resolution. That's kind of old school, what you would get on a TV way back in the days of 4:3. That is going to be the lowest cost per second because it rendered the fastest. And we see actually something pretty cool. The 3078 gigabyte does really good here. Now, keep in mind, this rendered time column, it is factored in because I did render some of these for different amounts of seconds, because that was all that would fit, for instance, into the 8 gigabyte card and the 3060. And while I might have been able to actually squeeze in another second into the 720p for the 3070, I definitely could have hit 5 seconds for the 3070 8 gigabyte. So don't view this as you can't go to 5 seconds on a 480 on the 3070 on the 1.3. You definitely can. It's just I forgot to do that, but I am factoring that in here, so it takes care of all that in the math. I've got watts per video, and you can see like it's pretty reasonable, and then it gets really insane. So we have 12 watts all the way up to 41 watts. That's a big spread just among the different GPUs. So there's, if you have a higher electric cost, of course, quite a bit of difference that you would need to factor in. So it also, of course, makes sense that after that, we see a 4090 in the 720 column as the most efficient route that I have, that I tested access to. And that comes out to about 251 watts per video. Your cost per video, I think that is cool, is about 2.5 cents. So that's a 5 second video. Your cost per second is, of course, divided by 5 since there's 5, and it's a half a penny. So you get 100 seconds of local rendering on a 4090 for 50 cents. Now, that's not factoring in the rest of the machine. I keep saying, and I think it's really good advice, have an always on AI system is probably something that is a good, decent goal. Whether it's something that is super energy efficient or super powerful, of course, that is a decision that is very personal to everybody. But, you know, if you take a look also at the electric rate, 0.1 is not where most people are in the United States. If I'm not mistaken, boy, I think 0.25 might not be too far from where some of the coastal areas are. And you see that these numbers change dramatically. All of a sudden, instead of getting almost 100 seconds on a 4090 at 720 rendering locally, you're down to 40x. So now you're down to 40 seconds. So it is a pretty big drop just based upon your kilowatt hour rate that you have. Certainly 10 cents per kilowatt hour is something that I think, you know, I'm lucky is the way I look at it. Definitely there's another outlier here. That 3070 keeps coming back. Now, granted, This was only a 3-second rendered video, but I think I could have gotten 4 seconds out of it. That's what I really think, is I could have gotten 4 seconds out of it. And that would have actually been a really good ratio if you look at this in the value proposition that you get for a 3070. And that's pretty awesome. Now, of course, the cost per video is skewed really far down, but that's because 3 seconds versus 5 seconds. The cost per second is just really close to what we saw with the 4090. So I thought that was a pretty interesting finding. Also, I thought this was pretty interesting. The 3090 had a substantially worse performance than I thought it was going to. I thought it would be 4090, 3090, 3060 actually I thought would be after that, and then 3070. The 3060 is pulling up the tail here by quite a bit. And certainly I think this is a good demonstration of some of the value that may be tangible to people if they're looking at cloud versus local. Of course, like I mentioned, tons of other things to consider. And so I hope you've enjoyed this exploration down video generation with DeepBeepMeep for the GPU poor. And that allows you to run video generation locally in your own house. And hats off to all the people that make these amazing models, and especially the people out there tuning them so that you can actually use them on your system at home. And be sure to check a bunch of the videos that we've got in this channel's history to learn about things like that. And I want to throw a huge shout out to all of our channel members, all of our subscribers, all of our Patreon members, and of course, the people buying me coffees. Thank you very much for everything you do for the channel. And definitely let me know what you think in the comments about this. I think this is some interesting findings. I did not expect the 3060 to do that poorly, but the 3070 I didn't expect to do that good either. I think that's pretty interesting. And I've got to say, the 720 would be the only consideration I would make. I don't think rendering in 480 makes a lot of it's very low quality. Granted, I have a lot of work to do myself on getting the quality up, and this was not a let's check out how good Digital Spaceport can render quality wise. This was more along the lines of what is the value proposition at different GPU sizes, and certainly, as always, biasing towards a massive amount of VRAM is, of course, the ideal. It's just a very, very difficult used environment to even begin to do that. And of course, new, wow, it's been pretty rough out there. I know the new Radeon 9700 XTs are being reviewed pretty well. I don't know how they handle image generation though. So if you do know, make sure to drop a comment below, because I'm sure somebody will definitely be asking. Everybody have a good one, and I will check you out next time.